the oxygen molecule, O2, has...
So you can see, wonderful liquid oxygen, nice blue colour. So over here on the strongly oxidising, very around the structure. And these unpaired electrons give rise to colour, and that colour is blue. So blue is often perceived to be the colour of solvated or unpaired electrons. Lots of chemists are really scared when they see the blue of liquid oxygen, because liquid oxygen is very reactive. General way where there might be organic molecules, perhaps simple organic chemicals like hydrocarbons, grease, or perhaps a highly elaborate compound, then they tend to detonate and they tend to cause very energetic experiments. So
nitrogen in here, you can see liquid nitrogen, well, you may not see, is colourless. Okay, so this is liquid nitrogen, and what I hope you can see is that this magnet, which is a pretty good magnet, let me just show you here with my keys, that they stick pretty strongly to the magnet. The magnet has absolutely no effect at all on the liquid nitrogen. I can pull the magnet and nothing happens.
And then we're going to...
The same thing with liquid oxygen. So, careful of my shoes. The liquid oxygen. It's a very nice blue colour today. So now let's try it. Here's the magnet again. And if I take the liquid oxygen, you can see I can pull it right up here, because oops, it's not as magnetic as my keys, but you can see there's a really big difference. It sticks to the magnet. So you can see it really is magnetic.
To the oxygen cylinder, and he's going to fill up this gas jar with oxygen. And we're going to do a really classic experiment, the one that everyone learns at school, a test for oxygen, which is to relight a glowing splint. So we have a traditional gas jar full of oxygen. So here you can see we're burning a splint. Okay, so this is the wood burning in excess oxygen around us. Okay, so now what we're going to do is we're going to take the splint out so that it's just glowing. So if I blow on the splint, you can see it gets brighter. Now we're going to try and relight that splint by putting it into a very oxygen-rich atmosphere. So we'll move over to the jar and we'll put in our glowing splint. And you can see the flame comes back to life. So that's a test that everyone learns for an oxygen-rich environment.
What happened? What made that happen?
Well, the increased oxygen